See, when I say that, what do you mean by career in mathematics? Now, mathematics has got a wide range of career, right? So you can go into, say, for example, space. You can go as an aeronautical engineer. Even you can go into NASA. You can study astronomy. You can go into finance. You can go into research. A lot. So, what do I mean by a career in mathematics is that a career where you're thinking about mathematics, where you're going ahead with the core competency you have. So, right on your screen, I have laid down the basic, more or less a broad idea of what could be your career as a mathematics. So, watch on this. The first is physics. So you understand physics has got a very wide range of career in physics. You can be a research associate, you can be into lab assistant, you can be an engineer, whatever you like. The second is geology. Geologists also have a strong mathematical sense, and they go ahead and do a lot of researches and study into, the weather conditions, etc. But you need to work in extreme conditions. I've got geologists who are working at minus 27-degree temperature in various places. So that is one career option. Data science, I will pick it up later, because data science is one of the most emerging, hot and happening, and a very lucrative career in mathematics. Material science deals with mostly related to chemistry, solid materials, polymers, semiconductors. These things will teach you. Cryptography, yes, a great career in mathematics. I will explain in video what are the options that you have. Mathematical finance is, yes, not related to entirely finance, but you have to have a very good and a strong knowledge of mathematics, and you can actually predict the financial market. You make a trend analysis, you make risks analysis, so a lot of things are there. And ergonomics, it is something which is related to, I would say, use of engineering and scientific concepts to create a work environment that is friendly for the employee to work upon. So it includes concepts like anthropometry, the study of human body. So I can tell ergonomics, for example, right now I am sitting here. So whether I am sitting in a right position, whether my chair is accordingly, the distance from the laptop or the scene, the humidity, the temperature, the way of sitting, the posture, whether I've got a pain, whether my head position is something right or not. So ergonomics deals a lot with mathematics, but particularly mathematics which will be used for generating an employee-friendly work environment. So starting from transportation, logistics, sitting position, environment, AC, all those things are included in ergonomics. Engineering, I don't need to tell anymore. Engineering is a wide area which you can do. And statistics. It is huge. Most of the market researches, most of the things that you do in order to calculate the chances, probability, statistics are there. So I mean to say, you see now all those things, whatever it is there, you understand all of these are application based. That means you are doing this mathematics, or you're developing a career in mathematics in order to do good for the human beings, in order to improve the communication, in order to improve the sitting position, in order to increase whatever it is. So if you watch my earlier video in Einstein and Tagore conversation, I have made it a point that yes, any technology or anything, any knowledge is only fruitful when it is coming to research, when it's coming to useful to human mind, or when it is giving some kind of a benefit to human beings, whether it is sitting, standing, eating, going around, etc. But it should come to useful for mathematics, for human beings. So that is all in all what I call more or less an idea of what do I mean by the career in mathematics. So you can just look into that. This is a basic points of career in mathematics. To show you, just have a look at your screen. Now these are the options which are more into developing a mathematical career. So you see I have mentioned data research analyst, computer and artificial intelligence, hedge analysis, actuary, and data scientist. Now hedge analysis I'm not going to explain right in this video because it is too much of a financial kind of you do risk assessment, etc. But data research and analysis I will explain you in details. Computer and AI is also there. Now what I would like to explain you here is what is an actuarial science, or who is an actuarist. Now see, actuarial science is something which is very new to Indian context, and the competition is very low. When the competition is low, and if you can survive in this competition, you have got a higher kind of a prospect. So where the competition is high, for example, in areas of research where people are already, fighting into, there's no point in going until you are a Kurt Gödel or a Stephen Hawking. So actuarial science is something where we collect the data. So for example, we gather data from somewhere and then we try to predict the future. We try to predict the future of a financial company. We try to predict the future, particularly of insurance. So we tell you that, okay, if we collect those data, and then we can tell you, okay, you should give loan to that, you will go bankrupt, so don't go ahead with that. You should involve into this risk or not. You should take a step ahead in investment or not. So it is basically forecasting the future, collecting those data, and there is a huge amount of mathematics involved in it. So you need to be very good in mathematics, in statistics, in good communication, and you should have a logical reasoning. Why good communication? Because general people don't understand those jargons which you use in mathematical or financial terms. So you need to write out in a lucid way so that people can understand. So that is why I call it as a good communication. So it is a kind of a forecasting data. Now here it is something on your screen. You need to pass out what is called ACET, Actuarial Common Entrance Test. 50% is the cutoff mark which you pass, and then you should take up 15 papers in order to pass the examination. Now let me see if I have missed on something. No. So here I have taken a note that they help businesses and clients develop policies and minimize the cost of that risk. So you need to have an absolute great knowledge on mathematics, especially in statistics. And I can tell you one thing. This is an important point. You should remember that when you are going into any kind of a career development path, whether it is mathematics, physics, science, geology, anything, you should remember that you should go into something which cannot be replaced. Now, artificial intelligence and robots coming up, you can be immediately replaced with a robo, right? And then you will say, okay, bye, Shaunak, we don't need you. But actuarial science is something which cannot be replaced so easily. Why? Because you are predicting the future. You are predicting that, for example, I will tell you that what is going to happen in the next maybe 1 year or maybe 6 months, given the data distribution. So this is another important aspect, that when you choose a career path, choose a career where you cannot be replaced. It is irreplaceable by automation or intelligence. So actuarial science, because it actually, I would say, it depends upon human intuition of forecasting, it cannot be replaced. Capturing, processing, analyzing, manufacturing, and communicating. Okay, these are the important key points of what is actually a data science. Now, see, data science is something which is related to some kind of a messy, organized or unorganized data. So we collect those data and then we capture it, we maintain it, we process it, and then we analyze and we get up certain results. So we try to find out the trends, we extract the data, and then we interpret it. So you can see what I'm trying to tell you, that this is a data, not only data collection, it is data mining, maintaining data, extracting the information, analyzing, and then letting you know, okay, fine, so this is going to happen. Again, a kind of a forecast. So mathematics and statistics, especially the logical probabilities, this is one of the most important aspect of data science. Here in your screen, I have given you a figure, a kind of a Venn diagram. No, it's not a Venn diagram. Anyway, so here you see the data science falls in between mathematics, computer programming, and business. We need mathematics to analyze it, computer programming to process it, and the business idea in our mind in order to give it back to those. So another picture I would like to show you. So when we talk of data analysis, we mean this. So you see there is a cohort analysis, which is a visual display to the analysis to compare different groups. Regression analysis, which is which variable has an impact on what. Factor analysis, we take the data, reduce it to smaller data so that it is manageable. Cluster analysis, it is a group of set of objects so that the same group are more or less similar to each other and gives us an idea of what and the way we analyze. And neural network. Let me show you a picture. This picture actually shows you what is actually a neural network. Right. So you can understand there is a huge amount of mathematics involved in what we call data science. I would also like to tell you now what are the career opportunities. Here on your screen, this is an overall guide. I have mentioned a lot of positions, but these are more or less the options which you can get as a data scientist. So you see that data analyst, database admin, and this list is quite long. Coming to the eligibility criteria, what you should have in order to become a data scientist, first of all, you need to have a master's. You should have mathematics as your major. You can also have physics or chemistry, but mathematics as a major, master's, or you can have even a PhD. A good knowledge of statistics will be required. And here on your screen, I have shown you what are the mathematics which is required, right? Uh, so in this picture, you can look, the list is quite long and includes a lot of complex mathematics. And at the below, if you see, these are the three factors which you should harp on. A very good solid foundation of calculus, a great idea about linear algebra, and you should know probability. Because probability is something, if you see, it will come all the way whenever you are applying certain things in order to know the trend, risk, etc. So you cannot skip probability. So this is what, so I will repeat: engineering, MTech, mathematics as a major, statistics or MSc or anything. Along with that, you need to have those skills which I have already shown you, and obviously you need to be a very good communicator because you will be working with a team of other data scientists. So communication, compatibility, team management, these things will be required. So that gives more or less the eligibility criteria and the mathematics which will be required. Understand that data science is something which is very, I would say, a very demanding, highly paid job, but you have to have a very good understanding of mathematics. Computation. Now you see, in this part of the computation, I just don't want to tell you about computer programming. Let me give you an example. When we are solving big mathematical equations, so right on your screen you see there is something which I have written as MATLAB, logic, discrete mathematics, and so on. So what I'm trying to tell you is that big calculation, for example, finding out a solution of Einstein's field equations, or for example, modeling, simulation, algorithm development, these are carried on with a software which we all know as MATLAB. Okay, so what I'm trying to tell you is that computation with a good strong background of mathematics is wonderful. That means given a kind of a problem, say for example, you're given a problem to solve a particular kind of a, I would say, set of equations, set of complex partial differential equations, and develop a program into MATLAB. So how do you do? Now there are two people who would be doing that. You being a mathematician, you will be assisting that person who is into computer or AI programming, right? So go ahead and do that. How? So these are the steps: 1, 2, 3, 4, etc. It can be finding out a solution for black holes or enormous big astronomical figures. Now that person would be doing out for the I would say what the computation from the logic part, computer reasoning, artificial intelligence, etc. But what you would be doing, you know those figures, maybe calculation of black holes, Schwarzschild radius, or huge amount of astronomical data which you already know how to calculate. So you do that. So computation doesn't mean that you just go ahead and do programming. No, I'm sorry if I have not been able to communicate in the right way. Computation means that you would be doing discrete mathematics, you do understand partial differentials and many other things, and you, along with the help of that person who is an expert in computer, will be developing an algorithm, a system, a frame of equations which will help people to easily solve out problems. So algorithm development, and if you already know computer, excellent. So you get a double or maybe a triple salary because you're doing two people's job. So if you do have AI, or if you don't have, if you have got a strong knowledge in any kind of a mathematical, I would say, subject which you're strong at, go for these kind of developments, MATLAB developments, theorem developments. That means you're extending a theory, right? If you remember Bernhard Riemann extended on Gauss's theorem. Maybe Gauss developed on some other theorem. So theorem extension, when you do, it requires huge computation. Who will do that? It's not possible to do it in hand. They develop an algorithm. So that is what computation is, another career option if you are right on the way of doing mathematics. If you are good at statistics, if you really like chances, if you really like probability, this is absolutely the right career for you. Here on your screen, you see you can be an economist, you can make policies, there is an actuary market, there is also market researcher. So statistics is another thing which deals with probabilities, chances, and as you know, the business market is always volatile. The business market is always ups and downs. You really don't know what is happening. So if you are really good in statistics, you can take up statistics as your career. It is going to bloom. You are going to prosper. You're going to get a very handsome salary if you're really aware about statistics. So statistics, one part can be into pure research, where you're not dealing with business hubs or financials and corporate houses, or you can use the statistics. It is more of an applied kind of a thing where you can use that in the market to forecast and make life look more beautiful. Have you really wondered that when you punch your what you call ATM card in the ATM machine out there, how secured your data is? When we go to online shopping, we punch our bank details onto online. When we do bank transfer, NEFT, securing the payment, all those things. This is what is called cryptography. Now, cryptography is basically, I would say, an interdisciplinary kind of area where a lot of things are taken care and it ensures data. So as you understand, I being an individual, I always want my bank account and everything to be secured. The shopping malls or the shopping centers, they want their data to be secured. You want your data to be secure. Every one of us wants a data security. So here on your screen, these are the possible openings which you have as a cryptographer. So you see security engineer, cyber security, crypto analyst, as everyone wants to protect their data, right? Now, here on your screen, you see this picture shows the mathematics involved, and you can see that it is quite an advanced mathematics. So if you are willing to develop a career in cryptography, you have to get a very good understanding of what is shown right on your screen: linear algebra, ring theory, and everything. And apart from that, number one, number theory. Now, what I would like to tell you, say for example, I am coming to your house, I am Mr. A and you're Mr. B. So you have given me a key so that I can just unlock your door and step inside and have my cookies. So I get a key, right? I open the door and I, step into your house. So this is what is called a symmetric kind of a cryptography, right? What happens next is that you give me that key, I come to your house, and there is a door. I open the door and I find another key. So that was one was called a public key. I'm not going into the technical details. And then I find another key and unlock the door and I open up and step inside your house to have a cup of coffee and cookies. So that is called a private key. So there are different, versions of cryptography, which is called symmetric and then asymmetric. And there are areas called confidentiality, non-repudiation, integrity, authenticity. So what actually cryptography does is that they make your data secured. And how will they make your data secured? That is through mathematics. That is through number theory. That is through combination. That is through linear algebra. So cryptography, if you go back and read a little bit, you will see there is nothing new. Way back during the Second World War also there was cryptography when the Allied force used to send some data and the Germans used to get hold of those data, and either way. So cryptography is nothing new. It has been happening, right? If you read Simon Singh's book, I forgot. I just forgot the name. So it's a good book on cryptography. You can search it with his name, Simon Singh, and it's a wonderful book on the history of cryptography. So cryptography is going on. And what I would like to tell you, with this current era, when pandemic has hit us and everything is going online, people want more security. So people are venturing into securing their data. Corporates, business houses, researchers, they all want make their data absolutely confidential. So cryptography, I know it is a new concept in India, in US and other countries where my friends are, it is quite common. But as I told you, that you need to have a concept where you can really thrive that the competition is less. So just to tell you more, that cryptography would deal with mathematics. You have to have absolute great understanding on number theory, and that is the key to success of cryptography. I've already shown you what are the different type of career opportunities which are available. It is good, you can go ahead with that. Financial mathematics. Let me show you what is on the screen. Right there on your screen, you can see that what actually financial mathematics deals with. So you can become an actuarial analyst, you can become a chartered accountant, risk analysis, everything. My basic idea of showing you financial mathematics is that finance which was 20 years back is not the finance which is right now in 2022, or maybe the 10 years to come. So there are a lot of mathematics which is being developed in the process of, thanks to the pure researchers, a lot of areas have been developed in pure mathematics, and which is making finance even more challenging, which is securing finance, which is helping the business houses to forecast, to invest, foreign investment lot. Now, I know you being a person from mathematics, you won't be interested in finance, nor do I, but I just wanted to show you that this is also an option. This is also an area. And I have seen in my college days that chartered accountants, I don't want to say college did, but in my young days, chartered accountants who are coming from a commerce background, rather the chartered accountant is coming from a mathematics background, they are doing better. A chartered financial analyst coming from a strong mathematical background is doing much better than those people who are for commerce. So as I told you, that mathematics give you that kind of a brain where you can do analysis much better. So mathematical finance is definitely a go ahead. If you're a little bit interested in finance, if you're a little bit aware about the business happenings around, you can take up this skill. Meteorology. Now, really, have you ever wondered that your strong skill in mathematics can save a village from a tornado? Your strong skill in mathematics can save a country from an earthquake. A strong mathematical sense can take you into what is called meteorology. Now, you see, the importance is immense. As I told you, you can be a meteorologist provided you have a good amount of grasp in mathematics and physics. Okay, so first let us look into the eligibility criteria. So this is the eligibility criteria, and writing skill is very important. So this is a note of attention. So those who are very good in writing English, because again, meteorologists use a lot of technical skills, lot of technical words which are into physics, chemistry, weather science, and in mathematics. So you need to write in a very lucid way in order to get a good career in mathematics. So coming to the next part, which I was telling, that this actually shows the mathematics involved in meteorology. So you see vector calculus, fluid dynamics, calculus, geometry, algebra, and so on. Now, you see what happens is that when there is a wind flow, there is a hurricane coming on. So you really try to predict all those things using this part of the mathematics, which is vector calculus. You have to have a very good understanding about fluid dynamics, otherwise you won't be able to work out. So you see that what is happening, that if you become a meteorologist and if you go into meteorology, you are already using your English communication, I mean to say the writing communication, and the advanced mathematics that you have, because fluid dynamics, vector algebra, calculus is an absolute, because you're taking so many weather, wind, humidity, all those factors. So you have to have a great understanding on partial differential equations, right? Geometry will be required, algebra, and quite a lot. So meteorologists do need mathematics, and if you do have, please go ahead. It is a wonderful career. It is going to save lives, and you are going to enjoy.